Hello and welcome to our virtual Lunch and Learn today. We'll be talking about industrial network triage. My name is Rachel Green and I'm the Digital Communications Specialist here at McNaughton-McKay Electric Company. And presenting for us today will be Jay Lloyd, Solutions Architect out of our Charlotte, North Carolina location. Out in the comments section, ready to answer your questions, is Kevin Riney, Network Engineer, also out of Charlotte. We'll have a Q&A portion at the end for Jay to answer your questions in more depth as well. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us here. As you come in, let us know where you're tuning in from in the comment section. I see Tom is joining us from Michigan. Hi, Tom. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist, and we cover a new topic every Wednesday at noon, so be sure to join us on your lunch break. For anyone just joining, welcome to our virtual Lunch and Learn Industrial Network Triage. Let us know where you're joining us from. Hi, John from South Carolina. Thanks for joining today. We'll be looking for your questions as you have them in the comments while our presenter, Jay Lloyd, discusses the process of pragmatically addressing industrial network issues. Our specialist, Kevin Riney, is ready to respond to your questions in the comments and chat with you as we go along. And we'll have a Q&A segment at the end of Jay's presentation. If you'd like to reach out afterward or if you have further questions for Jay, you can send us an email at mcmclive@macamac.com. Be sure to let us know which session you attended and we'll direct your questions to Jay. And we'll have that email address on the screen for you at the end of the session as well. Hi, Leanne. Hi, Stephen. Thanks for joining. Looks like we have quite a few attendees with us now, so let's go ahead and get started. Jay, I will pass it over to you.
I'm Jay Lloyd, and this is Industrial Network Triage. So what do you do when you have a problem? Google defines triage as a medical term for addressing needs with the appropriate resources based on the severity of the need. And I kind of like to think of your industrial network in the same way. So where do you start when you have a problem? Well, you start with the physical media, of course. But if you've checked your connections and they seem sound, now it's time to move on to a little bit deeper layer. And we'll go over a few areas here this afternoon in this short presentation. One, talking about the network. Two, talking about some of the devices on the network. And three, the applications that are running across the network. Because your issue could rely in any one of those distinct areas. Just remember, safety is always the first priority. Pilots use a checklist, and we recommend so should you. Consistency is key to achieving reliable results. Developing and borrowing some best practices, then document your best practices along with any tribal knowledge that you've acquired and share your experience with others so that you can be more effective at your job and everybody else can as well. So it depends on where you start. How severe is your issue? If the line is down, if production is impacted, and it's a severely costly scenario, call in the experts immediately, whoever that might be in your team. If you have a vendor or remote support agreement, don't hesitate if it's a critical issue. Most times, though, in networking, we'll see intermittent issues. It's urgent, but not keeping a line down, might not be critical. So now we should probably put a deadline on how we're going to start troubleshooting. And lastly, the occasional nuisances. If you have time in the day job and you can get rid of those nuisances, it's amazing how much better your day can be when you start to chip away at those little issues that don't seem to be too big at the time, but they can certainly add up, and we'd like to get rid of those as well. Take notes, document what you're doing. That way you can review what you've seen. Humans are notoriously terrible eyewitnesses. Just because we remember things differently, our perspectives shape how we remember things. If you write it down and you're prepared to share it with somebody later, chances are you'll have a good idea of what happened and what you're doing. Prioritize and attack the problem. First off, I wanted to cover a few quick concepts. So we only have about 8 slides here, and we're actually going to get into the tools and methods that I like to use when I'm troubleshooting a network. But first and foremost, managed versus unmanaged switches. Simply always use the managed switch whenever possible. Managed switches provide security, they provide diagnostics, they provide loop protection, and you don't get any of that unfortunately, with an unmanaged switch. What kind of topology are you dealing with? In many cases, we see flat, sprawling networks. Things are unplanned, they grow over time due to sprawl, and things work well until they don't. On the other side of the coin, you have reference architectures, validated designs. We'll talk about things somewhat from a Rockwell automation slant, since we are a Rockwell automation distributor, but everything we'll cover here today is going to be vendor and protocol agnostic. This is Ethernet. Doesn't matter what protocol you're talking, doesn't matter what vendor you're using. All of these concepts and the tools that I'll mention that are freely available can be used on any Ethernet network. If you've got a standards-based network, there you'll have some references to help guide you through your troubleshooting journey. Otherwise, you're going to be dependent on creating your own path forward. And what are your device requirements? Oftentimes in an industrial control system network, it's not about pure speed and bandwidth. We're not pushing 4K video, in some cases maybe for surveillance or monitoring, but generally it's about smaller payloads of information that are time critical. So what does the device require? Is it meeting its requirements? And are other devices on the network being overwhelmed? Even if it's not a large amount of traffic, maybe they're just not capable of handling that. And we'll go through that here in a moment. The first approach is to be academic, hands-off. You might be thinking, I want to see some tools, I want to press a button, hit a black box, get some information. That's all well and good, but if it's a critical situation and you've already got a network that's not robust, you don't want to take a chance and cause even more problems. So observe and record. Try to review and document some recent activities. What's changed? When do these changes happen if possible? This is where taking some notes is key, because it's tough to keep everybody on the same page unless you document it. Then start to look at some targeted diagnostics, and we'll show some of that here. Looking at device logs, looking at diagnostic web pages. These are minimally invasive things that generally will not cause issues on your network or have a very low probability of disturbing anything any further than it already is, but can be very helpful in pointing you where to go and what to do next. If you can, create a backup of any device configuration that you're about to work with. At least be able to leave things where you found them when you leave. If you can't make improvements, definitely don't make things worse. And the best way to do that is, when possible, make sure you make backups as you can. And if you are having problems, is it safe to restore a previous configuration? Don't want to just blindly reset to a previous state in time, but during the troubleshooting process, that might become an appropriate measure to take. Plan your attack, but again, think first, do no harm. Take a minimally invasive approach and then gradually progress to more invasive actions. So what can you do? Some potential triage action items. Definitely make a quick sketch of your network. It's nice to have a map. In many cases, you might have a spreadsheet of IP addresses. You might have a full-blown documented topology, but more likely than not, you're inheriting something that's there. So start with a quick sketch. Doesn't have to be in AutoCAD or Visio. Those tools are great if you have them, but to document what you have. If it's an unknown situation, I definitely advocate looking at the diagnostic web page of a device. I'll show you one of those in a moment. Doesn't cost you a thing other than your web browser and a device connection. And that will give you some cues on whether it's safe to proceed and use more invasive tools, or if you have such a critical problem that you have to revise and come up with another approach. I mentioned what we'll talk about here is agnostic. In this case, though, I will show you some of the Rockwell Automation Factory Talk Links communication driver. It's a free piece of software, and on any Rockwell Automation PLC or device, it's probably what you're going to use to communicate. It's a very good indicator of some things on your network. Taking a network inventory. Once you've got a sketch and a list of what your devices are, document their addresses and their information. Show you some tools that help you do that quickly and easily. Capture those switch configurations. When you have a managed switch, there are certain properties that are set up. There's diagnostic counters and information. Some switches even have fancy features like time domain reflectometer. What does that mean? Well, if you got a copper cable, a switch can tell you how long the distance of that cable length is. And if there's a break, it can help you find out where it's at. And moving on to things like packet capture and traffic analysis. This is kind of diving deeper. I like to save it toward the end of our list, because if you start capturing traffic in the beginning, perhaps that'll be helpful, but more likely than not, you'll spend a lot of time going through a large amount of traffic, and you're best to start off with what are the requirements of the devices, who is trying to talk to what is the timing requirement, and then do a traffic analysis by putting those items in context with what you're collecting. And when you do a packet capture, a short burst is generally sufficient. If you're trying to catch an item that you can't predict when it's happening, it's good to set up the laptop perhaps and let it do a packet capture in rolling periods of maybe a half hour or an hour. Then once the event happens, you can look at that file and narrow it down. Now let's kind of roll up our sleeves and look at going hands-on and actually doing some active things. And if it's safe to do so, if we've looked at some of our previous steps and we determine that we can interrogate the network without jeopardizing performance or impacting production, proceed to using some more aggressive tools to get some feedback of what's happening on the network. And this is probably what everybody wants to see, the tools. Here we're going to discuss the tools that are available. Again, every one of these that I'm about to talk to are free, or at least have a free limited version of the tool. Some of the content will be biased toward Rockwell, but the intent is to be agnostic to anything Ethernet. Most of all, every vendor probably offers documentation on their device, so that's another good resource. Going online, looking what user manuals or general troubleshooting guides are available. This will help you hone and develop your checklist if you don't have one. I mentioned using some of the visibility tools that the various vendors offer. In our case, I'll show RSLinks and RSWho. RSWho will give us a graphical interface of what's on the network. And I mentioned it's good to capture an inventory, a list of what those devices are. We'll show you the system Ferret tool and how that can do that automatically for you. Rather than looking at dozens, potentially hundreds of devices and manually transcribing that information, well, this tool can do it for you in probably under 5 minutes, if it's safe to use it. Collecting PC information. I talked about the network, the devices on the network, and also applications. When you're dealing with applications, are there Windows error logs? Are there software-specific error logs? Are there diagnostic? What is the network interface connection configuration of your PC's Ethernet card? You can manually go through and collect this information, but just like System Ferret can help you collect device information, this little freely available script will pull those files off of a Windows computer, and we'll run that live and show you an example of what that looks like. I carry it on a USB memory stick, but in some cases, security policies may dictate that you get that off of an online shared drive, or perhaps email it in a secure method to use it. But the tool can be done either way. Using the web interface to make some observations is great, but again, in helping you capture that information, there's some web crawlers and free tools that are out there that will actually go and capture that information, save it to an offline file for you so you can review it later. That can be very helpful. And again, all of these tools are designed to be used in a light, quick manner and help you collect that information without burdening you from creating all the documentation. Also, maybe forecasting. When we talk about the devices and their needs on the network, how do we anticipate how much bandwidth or what the connection speed will be, or if a particular asset can handle the communication of all the devices that it needs to configure with? I'll show you an online tool that can help you predict that in advance. And even in a more complex scenario, we can build out and model an entire network in a tool we call Integrated Architecture Builder. Links to all these tools are provided just below the video, so you can quickly and conveniently get to them. Going on the list, the final set of tools, the Task Monitor tool. If the controller is the center of the universe and responsible for network performance of all its associated devices, a quick and easy tool that can kind of show you the health and performance of the network from the controller's perspective. If you need to do some packet capture, Wireshark is one of the predominant tools available, freely available. But how do you analyze all that information? Well, we've got some guides that can help you set some filters and quickly determine what to look for. Maybe the problem is Windows. I've got a document on how to troubleshoot a Windows network. We won't go through that in detail, but we'll have a link if you wish to use it. And if you are using managed switches, the configuration and monitoring tools that are available. That can start with a simple web interface. It might be a console, cable, or command line basic rudimentary interface. It might be available through other software packages you have. If it is a PLC network, looking at the PLC file, examining the configuration, the type of messaging that's happening, the controller configuration, the requested packet interval update times, all of those things can be helpful in determining the load on your network and what an offending issue might be. Combining that with the capacity tool that I spoke about earlier and that we'll show you next can help you determine maybe where to start your troubleshooting and offer you items where to provide relief if it is a communications related issue. And then the holy grail, being able to monitor your network, create a map of all your devices, let it go out and discover them, create an inventory list of all those devices. We offer a product called FactoryTalk Network Manager that can do some of those things. Spoiler alert though, to make those beautiful maps and all those things happen, there have to be things in place and configurations like setting up managed switches, creating a simple network management protocol group, allowing switches to discover each other. And those things, if they're not present, you'll see a dot with a bunch of devices around in a sphere, and it kind of looks like an ambiguous blob. But you can still get a device list. Network Manager is available in a free version. If you actually want to start getting diagnostic logs and troubleshooting or configuring devices, then there's a license sold for additional capability. We have a separate video complete on Network Manager, so we'll have a link to that in the description down below, or you can search Network Manager on the McNaughton-McKay YouTube website. However, I did want to show a few features. That pretty map of going out, discovering devices, the switch, the associated devices, switch-to-switch connections. Here in Network Manager, you'll see things like network speed, the type of link, the particular port on a switch that's being connected. It can also be helpful in detecting changes to your network. Has something new appeared that wasn't there before? Has something dropped off that should be there? A quick and easy dashboard and a way for you to view that without having to go to every device. A little bit better view of that topology. So now I'm going to break out for just a few moments and start showing you some of these tools that I spoke about. RS Links will be the first tool. And live here with me, I have a very small network of a few devices. Got an Ethernet switch, got some communication modules, got some distributed I/O, operator interface, some controllers. And we can navigate through this interface. We can see what we're connected to. If we drill down into a device, we can find some helpful information about that device. We can look at its properties. Maybe one of our PLC processors here will interrogate. And we'll pull up information about it. What version of software is that product running? What is its electronic serial number? Versions can be helpful with firmware. Many devices have their own internal operating system. As you update them, if there are security patches, fixes available for issues, you might want to know what are you currently running, and then you can go out and see what the latest update for that device is. Read the release notes quickly. If there's a known issue or anomaly that's been corrected, maybe that's the right update for you. If you already have the latest version, then you know there's nothing more you can do there. Continue on. So what System Ferret will do is as you go through this RS Links communications software, System Ferret has the ability to go out and capture all of that data for you. All you have to do is have RS Links running and have a connection to your network. It will find any Ethernet IP device for you, and then it will document it in a convenient file. You just have to tell it where it's going to go look and give it a file name for where you want to store that information once you're done. So we'll browse down just to this Ethernet network with less than half a dozen devices. We'll store that file in a little temporary location so we can look at it together in a moment. And it has the ability to create a couple different outputs. It'll create an XML file, it'll create an Excel file, which you can look in a spreadsheet, or it'll create a text file. So don't even have to have any software tools other than the free RS Links communication driver and the system Ferret to run that for you. While that's cooking in the background, I'm going to drop over and show you the Ethernet IP capacity tool. Here we're kind of doing an active diagnostic scan. If we wanted to do some modeling and determine what's actually on our network, let's take a look at what that might look like. The Integrated Architecture Builder, again, is a free software utility. We've provided links where you can access that. It has a number of features, but we're specifically going to focus just on the Ethernet capacity tool. And while she comes up, one thing I did mention, not only using RS Links, but just using a web browser to look at the diagnostics capabilities of a particular module to kind of gauge whether it's safe to use more aggressive tools as you move on. We'll pick the Ethernet module in our PLC chassis. We'll interrogate its web page. It should immediately confirm some basic information about that product. There we know that we're connected to it. This could be an Ethernet module. This could be a variable frequency drive. It could be a piece of process instrumentation. Just about any Ethernet device probably offers a diagnostic web page. Now that we've known we were connected to the target device that we seek, again, we see its firmware, how long it's been up and running. You can look at the diagnostics overview and looking at the CPU utilization. This is the central processing unit of this communication module, and it is at a whopping 1%. So this network, extremely lightly loaded. We're probably safe to use some tools to take a look at some things. We're not going to add a significant overhead and overwhelm this network. If this figure is sitting at 70% or higher, I then tend to be much more cautious. I don't think the network has a lot of extra time available to handle maybe some of the diagnostic tools I might be using, and I would look at a very special approach to handle things, maybe when we're not running production, if we can wait till we have some downtime. She is taking her sweet time. When we open the Integrated Architecture Builder, there's a couple different wizards to use its various features. We're going to look at the Ethernet IP capacity wizard. And again, what this will let you do is kind of theoretically model out what's on your network. I've already started a configuration for us, so we will take a look at that one. It's pretty easy to use. It's kind of a basic interface that looks at, in this case, the controller as the center of the universe, and the devices that that controller is going to service, control, communicate, talk to. The nice thing about the tool is it's quick and easy to use. You'll be able to configure the devices for your configuration, how fast you want those devices to update. And that's what can be key, because in many cases, if you have unmanaged switches or a network with a lot of multicast traffic, it might not be a lot of traffic for the switch or for the processor, but a label printer, a variable frequency drive, might only be able to handle 400 packets per second or less. So while the controller can handle 10,000 or more packets per second, if you've got a flat network with unmanaged switches, a lot of devices are going to be spending time rejecting traffic that's not intended for them. And in that case, that could be causing some intermittent issues. Generally, when a device has a connection, it will maintain that connection. It will maintain control. It will continue to operate. But being able to inquire to that device to get diagnostics, or if its buffers do load up, it could have an unpredicted result and need to be reset. Power cycle to the communication adapter. That might not be convenient if it interrupts production or stops your conveyor from running. So here in the case of the Ethernet IP capacity tool, we've chosen a ControlLogix processor. It has embedded communications. we're just using a generic 48 port switch. We could select different type of switch if we were using a different port density or using one of Rockwell Automation's available switches. We can look at managed or unmanaged switches. So we go through the tool, we pick the switch that we have. Again, I've chosen a generic 48 port switch. And then in this case, you can have up to 8 devices around the switch connected to this controller. And in our example here, I've chosen 15 variable frequency drives talking at 20 milliseconds. So that's 50 times a second these drives are talking to the controller to confirm their velocity or speed command. If this is a small conveyor, probably don't need to talk at such an aggressive rate. But in this case, we've got 15 drives at 20, 2 drives at 50 milliseconds, so on, all the way to a couple down as low as 200 milliseconds, so 5 times a second. Some talking at 50 times per second, some talking at 5 times per second. Why is this? Well, by default, devices will attempt to communicate at 20 milliseconds. So it might not be a design intention. It might have been just whoever was programming this accepted the default values. And in this case, we can model this out, hit the compute button. It will run a quick calculation theoretically of what that processor can handle, what those devices are configured at, and everything's green. So green is good. Yellow or red would be progressively worse. But bottom line here is, even with these 28 drives, some talking at fairly aggressive communication rates, it's only taking about 17.9% of the communications bandwidth utilization. More than safe, more than adequate. That controller is not taxed whatsoever. As long as the devices aren't being overwhelmed with communications at each other, this is a fine network. So you can print this and save this, create a snapshot. This free tool gives you a way to help document what you have. You can do some more aggressive things and build out a complete network, but I just wanted to show you the quick and easy capacity tool to run. The system Ferret, in the meantime, had finished its task. So let's go to that folder where we created a file output, and let's take a look at our options there. I mentioned in the system Ferret, you can view as a clear text file, as Excel, or as an XML file. So let's take a text file, see what that looks like. And on my network, well, that's legible. I can see my switches, my Ethernet modules. I do see their firmware revisions, their electronic serial numbers, their position in the backplane, so on and so forth. Might be a little bit nicer to see that in Excel. After you run the scan, it just takes a moment or two to create that output file. Here's my temporary folder where I told it to save that file, and we can look at it to review later, email to share if necessary, or just keep that with our documentation. Also talked about collecting application files and what's happening on the PC. Is it an HMI that's PC based? Is it some other database data collection application? What is the Ethernet configuration of our computer? If it's safe to do so, I run a virus scan on my USB stick. I keep my utility so I can take it out to the field. Simply connect it to the PC in question. And we'll open it up in Windows Explorer. Tidy things up a little bit here. And this collection document is basically just a small script. You tell it to run. It does have the ability to run over a network to a network computer, but I'm going to run it on the computer that I'm on right now. So you just open it up and click OK. It says it's going to proceed with collecting information, so we'll let it run and do its task. Generally takes about 3 to 4 minutes, but what it will do is, along with a collection of files, it will create a spreadsheet for you. You can open that up in Microsoft Excel, and you'll see the network configuration of this computer. We'll match that up against what we actually have with our network adapter to know and verify that that's really what we're seeing. but a very helpful tool to document a lot of information. The most tedious thing that it's good at doing is getting all the software that's installed on a computer and when it was installed and what versions are installed. If that becomes an issue, this collection tool is a great way to document that and put together what you have. So we're going to look at the status of our Ethernet adapter, my IP address that we're using, and then we'll take a look at the output of the data collection tool, verify that we're seeing the same things, same software. 192.168.1.50, that's what's actively communicating to our software right now. And while that finishes its task, I'll show you the task monitor tool. This will be the one thing that is specific to Rockwell Automation Logix 5000 based PLCs. But it is a free utility, can be run standalone. And if you know you have a Logix 5000 based PLC, you simply point it at that controller. It will use that free RS Links communication software that we used in the previous examples, and it will collect information about that controller. And there's my target of choice. It's going to retrieve its information, scan for all the devices in the chassis and connected. It will give you a live running update of what it's observing. This can be helpful if your controller is the source of your intermittent communication issues. If it's overburdened or overwhelmed, this gives you a quick 10,000-foot view into what it's seeing. We already looked at its Ethernet module. We saw it was at a whopping 1%, so we knew that this network is not taxed. We can go ahead and run a tool like this, let it collect some information, and then quickly see what it can present to us to decide where to troubleshoot next. That finishes up. Our system Ferret had finished creating its Excel file. I'm going to give you a little peek at what that looks like as well. You saw the text version. But if you want to search for things or make changes, Excel can be a more convenient tool to do that in. And even waiting for a few moments for these files to open, again, to go out to every device, to take a half a dozen, 20, 100 devices, document all that information, it pays dividends here to have a tool to automate that process for you. Our 10-port switch, its part number, its firmware revision, its electronic serial number, its IP address, everything quickly and conveniently documented for you to have a picture of what is on your network. Help you make decisions on where you need to spend your troubleshooting efforts, what is losing connection, what device isn't getting the resources it needs. All of these tools kind of give you some various views into the health and status of those devices. And usually the task monitor tool is the quickest of these tools, but she is taking a little bit of time today. I think I did run one a little bit earlier. Might take a quick peek at that, my task monitor test. And just like when you go out to dinner and you leave to wash up in the restroom, your food will arrive. Hopefully, as I pull this report up, the task monitor tool will come to life and we'll show it to you live. Just a moment, we'll see a web browser open up with the report of the task monitor, and I'll kind of just show it to you backwards. I'll show you the results that it delivers, and then we'll move to the live view and show you what it's collecting as we go. And here we are. Again, kind of big on documentation. It's nice to have a copy of what you have. So if you forget the details, you can go back later. Want to expedite the time it takes for you to get this information and quickly look at it. There create some links for you, but we'll just kind of scroll down through the page to see what the task monitor has captured for us. It is actually on the live processor that we're looking at right now. The controller itself is using about 0.02% of its CPU. So again, a very lightly loaded system here. It should not be processing power. It should not be code or application requirements. If we're having intermediate issues, it's probably related to the network or physical media. If we look at the total number of communication connections that this will support, 512. We're actively using 3. A maximum of 5 were observed. Again, very lightly loaded. Good information to quantify and explain that, yes, this device is healthy. I can focus my efforts elsewhere. I have seen applications where we'll see high connection rates, and not suggesting that it's best to solve problems by throwing money at them, but sometimes if one module is overwhelmed, there might be a higher capacity module. And simply putting in a new piece of hardware with more capacity can alleviate congestion and solve issues. As long as you've quantified that and determined that's the right approach to take, then you can justify it. Just going out and spending money on more hardware without having some evidence to back it up can be a little bit tough to justify. And we want to make sure that our customers remain profitable. They use their time and money resources wisely. That's why I wanted to show the capacity tool modeling offline example, and then looking at things actively online to confirm what our situation is and deciding what appropriate steps to take to remedy that. Do we need to purchase a higher capacity piece of hardware? Do we need to make configuration changes to our programmable controller to what the update rate for those items are? If my conveyor drives are talking at 20 milliseconds, 50 times a second, my hardware can certainly handle it, but if they don't need to, if the conveyor moves very slowly, maybe 4 or 5 times a second is more than adequate to keep up with that device, and we can save some of that bandwidth time for other devices that are more critical, or just save it for future growth. So by looking at these tools, you kind of get an idea of the health of the network, where things stand, where to spend your time, and you get some quick pieces of documentation to back that up. The Network Manager tool is probably worth taking a look at and spending some time. Again, we have a separate video on that can walk you through that product. It might be your first choice, but it's a little bit more invasive because it's actually doing some active scans. I wanted to show you some simple tools that are minimally invasive that should put no additional network load on other than opening up and running an RS Links scan, which most of our customers do every day because it's required to make a connection to their hardware. We're just using that communications connection to grab some diagnostic information. I appreciate your time. That pretty much takes us through everything I wanted to cover with you this afternoon. We'll open it up for questions in just a moment. But before we do that, let's talk about next steps. You've run this diagnostic information, you've collected some information. Let's try to determine what issues we have and how we're going to remediate them. Long-term, continue to maintain your documentation. Keep an accurate topology diagram. Once you troubleshoot and solve an issue, make it easier for the next person that has to do it. That person very well could be you. Move from triage kind of to more of an assessment approach. When you have the time and the availability, take a holistic look at your network. Is it meeting your requirements? If you're having intermittent communication issues, if you're not able to bring the new applications online, maybe it's time to make some improvements and move to a network design in order to create a robust, reliable, and more importantly than ever, secure network. I have one customer that tells me if you can draw it, you can build it. And I say then you can support it as well because you have an accurate map, you have a picture of what you're trying to do. And lastly, in the news here recently with the pipeline incident, look at your industrial security policy. If things are air-gapped and separated from the business network as they should be, you're insulated somewhat, but it's just a matter of time before somebody with good intentions maybe accidentally compromises the network. You need to guard against that. The way to do that is with defense in depth. It's about using policies, enforcing policies with tools, with training, and with consistent behavior. And with that, I think we can open it up to any questions.
Great, thank you, Jay. We don't have any live questions in the chat at this moment, but we will allow a few minutes for anyone that has some follow-up questions for you. While we wait, I'd like to reiterate that you can reach out to us even after this live stream is ended, or if you're watching this as a recording at macamaclive@nc-nc.com, that email address there on the screen. We'll make sure to direct your question to Jay. Just make sure to let us know which session you attended so we can get it to him.
Well, thank you, everyone. Appreciate your time.
Yep. Thank you, everyone, for joining us today. We appreciate you. We hope the session was informative and engaging for you. Thank you, Jay, for a wonderful presentation, and to Kevin for being our resource out in the comments section. And we look forward to seeing you all live again soon. Thank you, everyone. Have a great day.